Good morning, students. Am I audible? Okay. What happened to others? Inform them to join. Okay. Anyway, so let's start. Fine. So good morning, students. This is a class of railway engineering, professional elective one. Okay. So we are discussing about the module three. Clear? So the module three of railway engineering is all about geometric design, the important design parameter, which are very important to understand before going for construction of a railway track or deciding our railway alignment. Fine. So in the last class is module three, where we were discussing about what we were discussing about the alignment, ideal alignment, or you can say significance of ideal alignment. Okay, and the factors that we are going to be considered while deciding a alignment for railway. Got it? So there are different factors. We have already discussed about different factors, um, which are uh, perform as a governing factor for deciding a railway track, or you can say the alignment of railway track. Okay. So in the very last class, we were discussing about the gradient. Okay, this is also very important um, parameter for design of railway track. Okay. So about gradient, we already discussed. I don't want to repeat again. So basically, gradient is what is it is a longitudinal slope provided along the railway track to connect lower to higher uh, elevated point. Okay, and there are four types of gradient. We already discussed about that, like uh, minimum gradient, then ruling gradient, then momentum gradient, and then pusher gradient. Okay, so about that we already discussed, and we also discuss about uh, grade compensation at curve. Fine. So we discussed in the last class about grade composition, that means compensation. That means in a particular curve path, when a particular train, hold on a second, okay, hold on a second. Sorry. So we are discussing about that grade compensation, right? So when it comes to curve, that means when a particular train moves from a straight alignment to a curve alignment in a particular case, in the particular section of curve, we should reduce the amount of gradient that is provided. Okay, so that a particular train should not derail from the particular original part. Okay, so about grade compensation, we already discussed about that. So, okay, in the last class, so we don't need to go for in detail. Fine. So in this class, we're going to discuss about curve and transition curve. Okay, that means circular curve and transition curve that is provided in a uh, railway track. Even this particular concept can be applicable to your highway engineering also. Okay, that means even in the highway engineering also there is a parameter was that means like circular curve, transition curve that are also applicable in highway engineering. Same way, even in the railway engineering also they are applicable. Okay, if you are already know these things about transition curve, circular curve, about related to highway engineering, then it becomes very easy to understand for railway engineering also. Okay, the basic concept is similar. Okay, so before going in the presentation, okay, roughly I'm going to give an explanation for circular curve. Fine. After that, we're going to go for uh, they're showing that your notes. Okay. Anyway, okay, I'll show you. I'm showing my screen. Okay, right now. Is it visible? I guess it is visible, right? Okay. So okay, let me take one pen. Okay, which color? Which color? Which color? Okay, let's take the red one. So anyway, so how to explain to you? Okay, let's say this is a railway track. Okay, suppose this is a railway track. Okay, and particular train is moving in this direction. Okay, now suppose because of the obstruction or suppose particular train need have to reach this point. Okay, that means at a particular for to connect this point with this point, what do we need to do? We need to go for uh, curvilinear path. We need to provide a curvilinear path. Okay, that means kind of this. Okay, isn't it? Fine. So we are not discussing about this intermediate part. Okay, for now. Anyway, again we can join this with a different color. We'll discuss about this part after some time. But for now, just try to understand that. Okay. Now suppose a particular train, or you are asked to construct a railway track connecting, suppose this point A to point B. Okay. So, and there's some obstruction, that suppose there is a hill or anything. Okay. So you have to follow this path. Okay. Now from this point to this point, you can see the path is straight. Okay. And to reach this point B, to reach this point B, to reach this point B, uh, to reach this point B, we have to give a circular portion. We have to fit a circle. Fine. And this particular, this curve, this section is a part of a particular circle. Okay, this is not a circle, it is a part of circle. Okay, it's an arc, and basically it's a part of a circle. Okay, I'll show you the other part of the circle with a different color, like this. Wait, assume this is a circle. Okay, although it is not look like circle, but consider this is a circle. Okay, like that. Okay, so I think roughly it is not exactly circle, but consider this is circle. So anyway, this is not exactly it's a part, it's just for to make you understand, I have given this dash color. Okay, so this is a straight path, straight alignment of a railway. Okay, and to reach point B from point A, this particular straight alignment should be curved. Okay, at some point up to this section, from this section to this section we need to give a curve. Fine. And this particular arc, you can say this arc is a part of a circle. This is a circle, and this outer rail also is part of this circle. Okay, and for this arc we can consider this is a center. I'll show you one center for here. I'll take another color. Okay, black color. Fine. Suppose this is a center of this circle, of the inner circle. Okay, and this is the radius. Okay, so similarly we can also draw a radius for this outer rail also. Okay, okay, that means to construct a curve for a particular railway track, we need radius. Okay, even though without radius also we can provide, if you know the degree of the curve. Degree of the curve means like that. The degree subtended by this arc at the center. This is your degree. Okay, the angle subtended by a particular section of a circle at the center, it's called a degree. Okay, and the radius, you know this, you know about radius, right? And about this also we have discussed about uh, degree and radius even in the last class when we discuss about grade compensation. Okay, so when we discuss about grade compensation in the last class, we what do we learn? That grade compensation, the amount of gradient that we are going to be reduced, that basically depend on the resistance. Okay, occurs in the curve. Okay, and that particular resistance, what resistance is inversely proportional to the radius, and this radius is the particular resistance of the curve is directly proportional to that degree. So we can write in the even in the last class, so we have discussed about that grade compensation, GC, grade compensation is directly proportional to the resistance occur in the curve, which is inversely proportional to the radius. Okay, and directly proportional to the degree. So we can write grade compensation is directly proportional to that degree. Okay, even in the last class also, for different gauge of railway track, like for broad gauge, for narrow gauge, or for meter gauge, different amount of grade compensation value are already mentioned, like 0.04%, 0.03%, 0.02% for broad gauge, meter gauge, and narrow gauge respectively. Okay, with respect to degree. Okay, these things already discussed. You can also check, cross check last class recording or last class notes, or even also you go through the reference books, any book you can refer. Okay, so these things already discussed in the last class. Fine. So anyway, how to remove this? Wait, let me take this part away. Up to this point, it is clear, right? Okay, anyway, so yeah, so this is all about circle. Fine. Is it clear up to circle? So let's go to that particular notes that I'm going to present to you. Okay, and one more thing, this is your long code for a particular circle. If you join the particular first point to last point, this is your long code. Okay, and the distance or the line joining the line joining from the peak of the curve up to this long chord, this point, it is known as what? This is known as versine. V. Yeah, I can't write here. Okay. Anyway, it is called versine. Okay, VERSINE, versine. Okay, the length, this line, that is the line joining from the long chord to the peak of the curve. Okay, it's called the versine. VERSINE, versine. Okay, anyway, so here is a radius, degree, versine. All these things are there. Fine. And one more thing you need to understand, that there is a this is a standard some value of radius. Okay, do you know what is the radius for this straight line? Anyone? Do you know anyone? For a straight, suppose this is a straight line. Okay, this is a straight alignment. For this straight alignment, what is the amount? What is the radius? Somewhere there is a center. What is the value of the radius? Anyone? No, these things, it's all mathematics. Anyone? पता है कि नहीं? A radius for a straight line होता है कि नहीं होता है? For a particular circle, any circle, we can measure there is a radius. Okay, definite radius will be there. But what about straight line? So as per mathematics, we consider the radius of a straight line is what? It is infinity. Okay, because a particular straight line, it is considered as a small section of a circle. Okay, that means if you, even in the circle, so if you can zoom it in a particular small section, if you zoom it closely, then you will see a straight line. Okay, but when you go for zoom out, you will see a curve. Okay, so from that point of view also, we can say for us, any straight line is a part of it is a part of a bigger circle, and for that circle the radius is infinity, since we cannot decide the center. Okay, but there is a center and there is a circle. A straight line is a part of a circle. So for a straight part, we can consider the radius of this particular straight curve is infinity. So this is also, we can say it is also a curve having radius infinity. Okay, clear? And basically, let's discuss about this part also roughly. So we don't provide the circle directly connecting to the straight line. Okay, so we can also do one thing, that we can directly connect this part like this. Okay, But we are not going to do this. We have to make it gradual increase of the value of gradient, value of super elevation, okay, from straight to circle, okay. And for connecting, in order to connect the circle or circular alignment or circular track with the straight curve, we introduce a new curve which is called transition curve, okay. And this part, basically this blue color part, and here you can see the blue color part. This blue color part basically known as transition curve, okay. And what is the purpose of this transition curve? It gradually increase the or it gradually increase the value of the gradient and super elevation that is need to be provided in curve. Regarding super elevation also, you already know these things in highway engineering, okay. We are going to discuss about super elevation again in the next coming classes. So you know this thing, right, about super elevation. What is super elevation? Super elevation is the amount of is defined as the rise of the outer rail with respect to the inner rail, especially in curve, this part, okay. So this outer rail is raised some amount, okay, with respect to this inner curve, okay, to counteract the centrifugal force. We're going to discuss about that in coming classes, okay. Anyway, so whatever the value of super elevation is decided from design, it is not directly provided. It is gradually increased up to this point from straight path to the circular curve. The gradient, we already discussed about gradient, which is the longitudinal slope. It is not, it is not directly provided in the circle. It is gradually provided from straight to circle. And this particular uh, gradual apply of gradient and superpolation is provided by introducing a transition curve between straight curve with the circular curve, even between compound curve. Okay. So that means the radius of the straight curve, basically is straight curve में कितना होता है radius infinity, and slowly is going decreasing from the point, from the value infinity to this particular design radius of the circle, okay. So we need to reduce the radius from infinity to this whatever value of this, suppose r dash value of the radius is we need to provide, but we need to decrease the radius, not directly, gradually. That means gradually is going on decreasing, okay. And what is the basic difference between transition curve and circular curve? In the circular curve it is a constant radius, okay. That means even here also it is the same radius r, here also everywhere it is radius r, okay. But for transition curve, suppose there is a particular center is there, so radius will be gradually decreasing, gradually decreasing till it reaches the value r. So it will decrease from infinity to this r, what is r dash, whatever it is, okay. So this is basic phenomena or a basic idea about transition curve and circular curve. Okay, understood? Okay, now let me show you anything, something else. Wait, this thing's clear, right? So I'll show you one more thing. Okay, now here you can see circular curve. So basically, what is circular curve? The main curved portion of a railway track is kept circular. That is, the radius at every point of the circle of the curve is same. Okay, the main part of the track, which basically directed the track of the train, it is curved basically. Okay, so you can see even in the diagram, it is a basic circle. Okay, the radius of the railway curve is sometimes represented by the degree of the curve. You already know, no, what is degree, what is radius. So even in this diagram, this length is radius and the degree is the angle subtended by this curve arc. Okay, so we can relate. There's a relation between radius and degree. We can consider it as it is inversely proportional. Fine. Here you can see we're going to come. We are coming to this formula. Okay. Anyway, when it comes to degree of a railway curve, when it specifically for railway curve, so degree of railway is basically defined as the angle subtended at the center of the curve by the arc of 30 meter. Here you can see 30-meter line. Sometimes 30.5 also be used in different book. Some in some books 30 meters given, in other books 30.5 also given. So don't confuse. Similar you can adopt. Anything you can adopt. Okay. And it is defined as the degree of the curve. Here even you can see the AB. It is an arc. It is a portion of a circle, and the length of the AB is what, 30 meter or 30.5 also you can consider, and the angle subtended by this arc AB at the center, suppose D. This is your degree of the railway curve. Okay, fine. Even I'll show you the notes also. Wait. Yeah, so we are discussing about horizontal curve. So basically, curve are introduced on the railway track. Curves are introduced on the railway track to bypass obstacles, to provide longer and easily transverse gradient, and to pass a railway line through a obligatory or desirable location. Anyway, this is the basic definition of horizontal curve. Okay, so a curve is defined either by its radius or its by degree. Okay, and a degree of the curve is the angle subtended at its center by a 30.5 meter or 100 feet arc. Here you can see even in the notes 30.5 is given here. Okay, so 30.5 also you can consider, or 30 meter you also can consider. Okay, anyway, so we'll come to this. How can we relate or this degree and radius? Okay, the very basic simple mathematics, so relation between degree and the radius of the curve. So say the r is the radius of the curve in meter. Okay, suppose this is the radius. Okay, this is the radius. Fine, this is your radius, and d is the degree of the curve. Here this is d is the degree, and you know about from the mathematic point of view, for a circle the total degree is what? Total degree is 360 degree. You know these things, right? And the total perimeter, circumference, you can say total circumference is what? Twice pi r. Okay, from this point of view, we can find out amount of degree for any respective radius. Okay, that means suppose for 360 degree of, for every 360 degree we have a total circumference is what? Twice pi r. Okay, now from this point of view, for this value of d, what is the arc distance, we can find out by this very basics equation. Okay, or basic relation. So for, if you consider 30-meter arc, suppose we are considering 30-meter arc, makes an angle d, capital D at center. So we can say this degree, subtended by this arc 30, which must be equal to do total degree 360 divided by total circumference, that is your twice pi r. Okay, that means the ratio of any angle subtended by this arc with the arc length, the ratio is must be equal to the ratio of the total degree subtended by the total circumference. It is a very basic mathematics. From this relation, we can define d equal to like this, and finally we'll get d equal to 1720 by r. It's very important to understand, some in some exam also it will asked. It may ask. Okay, so 1720 per radius. So we already know now that degree is inversely proportional to the radius, isn't it? So degree is inversely proportional to radius. You can see here also. And how can we relate? Degree is equal to 1720 divided by r. Okay, so this is all about your horizontal curve. Fine. Even here also it is already given, even r in meter. Okay, so these things already you can go for. Okay, so basically you should have to know about this 1750 or 1720. Just go for it. Okay, in meter it will come as, in if you consider r in meter, it will come in 1750 radius. Okay, and whenever you consider 30.5, but here you can see even here it is considered 30 meters, so that's why it is coming different. So it depends on what arc length you are considering. Okay, fine. So this is all about your circular curve. Fine. Is it clear to you? Okay, next, at the last, let's discuss about the relation between radius and versine. Radius and versine of the curve. About versine, we already discussed now. So basically, what is versine? It is a perpendicular distance of the midpoint of the chord from the arc of the circle. That means if I show you in this particular diagram, this is a particular circle. So this is a basically this is a curve. Okay, from DAE, this is a part of our, suppose this is a part of a railway track. DAE, and DE is the long chord. DE is a long chord. Okay, and the line AB, it is a line. What is the line? This is the line which is we are talking about, that is versine V. Okay, and by definition, what is the definition of versine? Versine is a perpendicular distance of the midpoint of the chord from the arc of the circle. Okay, that means perpendicular distance between these 2 points, midpoint of the chord and the arc of the peak point of the arc. Okay, so AB is your versine. Okay, and somewhere there will be radius. Suppose somewhere here will be a radius. Okay, suppose radius is r. That means the diameter of this circle will be your twice r. Okay, and suppose the long chord, that is the DE, the long chord length is suppose C. Okay, the amount is given as C. Okay, and radius is r. Fine. Now the relation between the radius and versine of the curve can be established as shown in figure. So we are already discussed about the figure. So let r be the radius of the curve and the C is the length of the chord and V is the versine of the chord length. V be the versine of the chord of length. Okay, and this is chord of length C. That means this is your chord DE having length C and V is the versine to this chord. Okay, that is AB is versine to this chord. Okay, and the value of AB is denoted by V, which is versine. Okay, now AC and DE being two chord meeting perpendicular at a common point B. Okay, now from the property of circle, you can see from this diagram also you can see this AC is a chord, DE is a chord, okay, of a same circle, and they are perpendicularly crossing each other. Okay, from this property of circle we can say AB multiply BC equal to DB multiply BE. Okay, here you can see we can write AB multiply BC, which is must be equal to DB multiply BE. Okay, that means this part multiplied this must be equal to this part multiplied this. It is a property of circle. Okay, now we know this is a V. Okay, AB represents V and AC, which is the diameter of the circle, given by twice r, since radius is r, so diameter will be twice r. Now what is the value of what will be the value of BC? BC will be diameter minus V, that is twice r minus V. Okay, fine. And this long chord, that is DE having length C, that means we at point B it is a midpoint of this line DE, so DB is your C by 2, BE will be C by 2. All values are already known to you. Now just put the value in place of AB, you write V. AB is the first sign. BC is what? BC is the BC, this value is twice R minus V. Here, twice R minus V equal to DB and BE have the same value equal to C by 2 and C by 2. So we can write finally twice RV minus V square. Okay, like this. Twice RV minus V square equal to C square divided by 4. Now in this equation, the value of V basically is very small with respect to twice RV. The value of V square, it is very small in with respect to twice RV. So this particular term, this V square value can be neglected, okay, since it is very small. Okay. So for simplifying the relation, since V is very small, the V square can be neglected from this equation, from this part, only from this part. Okay. So basically what will you can eliminate this part. So only what will left? this twice RV equal to c square by 4. It is square, okay, not 2 actually, c square, fine. C square by 4. And from this relation, we can find out V is equal to c square by 8r. So this is the basic relation between first sign and radius. Okay. So in this equation, V, C, and R are in the same unit, like meters and something like that. Fine. So you can also determine first sign using this relation if you know for particular curve, if you know the chord length and radius. If this radius and chord length is known to you, that is the value of C and R, if known, then we can find out first sign. So it is basic relation between radius and first sign of a particular circular curve. Okay, and some tabular format also given, basic recommendation like maximum degree, how much degree can be provided for broad gauge, for meter gauge, for narrow gauge as per Indian standard. So it is already given here, and the minimum radius which is can be provided. Okay. Okay, so about plane turn and for turnout is different thing. Okay, we are going to discuss about turnout. That means when particular two railway track cross each other, it is basically turnout. Okay, so in coming module we are going to discuss about turnout. Okay, it's a particular section in a railway track. Anyway, just go through this value. Okay, there are standard value that we need to follow. So this is our today class. We have we were discussed about horizontal curve. Okay, we don't have time for discussing about transition curve. In next class, we are going to discuss about transition curve as well as super elevation. Okay, we are going to discuss about super elevation also, and we are also going to do some uh, problem related to super elevation also. Clear? So this is all about today class. Till now, if you have any doubt, you can ask me. कुछ है पूछने का? नहीं है? I believe these things are you have already got in highway engineering. Okay, so it will be very easy to understand about, especially about geometric design part. Fine, similar to highway engineering. Little difference will be there, like different types of gradients are there. Okay, like this, and different value of gradient, standard value of gradient. We already discussed that amount of gradient, how much provided for different hilly area or plain area. These things are maybe different from the highway engineering. Even super elevation that we are going to discuss about that. The value of super elevation is also be little different depending on the different section of a railway track. Okay, we are going to also discuss about safe speed in coming classes. Okay, so with this, I just want to conclude my class. If you don't have any doubt, then I just close my sharing and I'll stop my recording. And after that, we're going to take your attendance. Fine? ठीक है ना? Okay, I'm stopping my recording now. Okay, fine. ठीक है, मैं stop कर रहा हूँ recording.